Hello, this is a short video presentation continuing our discussion on solving systems of equations by substitution. Yesterday we looked at equations that look something like this. Y equals, and you don't need to write this down, 2x minus 3 and 2x minus 3y equals 1. I'm going to erase it in a minute, so no sense in writing it down. We took the equation that was solved for y here, the 2x minus 3 part, and then we substituted that in for y. And we had 2x minus 3 times, and instead of y, we used 2x minus 3. 2x minus 3y, we substitute the 2x minus 3, and we solved. That's what we did yesterday. Today we're going to look at equations, two different examples that look like this. 3y minus x equals negative 4, and negative 3x plus 4y equals 8. Yesterday, I had all my equations solved for either x or y, all by itself. Today, we look and we see that's not the case. We don't have any equation that is solved for a particular variable. So what we need to do is solve one of the equations, solve one equation for x or y. I don't care which one, whichever one makes the most sense. So, let me erase this here. All right, so I want to solve one of my equations for x or y. What I'm going to look for is a coefficient of 1, a coefficient of plus or minus 1. So I see right here that my x term has a coefficient of negative 1. I'm going to solve this equation right here for x. So I have 3y minus x equals negative 4. And I want to get x by itself. So I'm going to add x to both sides. And then I have 3y equals x minus 4. Add 4. It doesn't matter if x is on the right or the left side. I get x equals 3y plus 4. I'm now going to take my other equation, like we did yesterday. This now becomes a problem just like yesterday. So my other equation is negative 3x plus 4y equals 8. So then I'm going to say negative 3 times whatever x is plus 4y equals 8. And then I make my substitution. X is equal to 3y plus 4, 3y plus 4, and I solve. I'm not going to finish the problem out, but it's exactly what we did yesterday. There's no sense in wasting our time solving this one. And we have another situation that we're going to look at. It's a little bit more complicated, but not much more. We have 2x plus 6y equals 2, and we have 4x plus 3y equals negative 5. Now the last example, I said, look for a coefficient of plus or minus 1? Well, there is none. I have a 2, a 6, a 4, and a 3. All right? So then, can I simplify an equation? Can I simplify an equation? And I see that the first equation, 2x plus 6y equals 2, I see that all the terms, all of these numbers are divisible by 2. 2, 2, and 2, which gives me the first equation equals x plus 3y equals 1. Now, my first coefficient my first term has a coefficient of 1. All right, that's what I want. So now I solve this equation for x, solve for x, and I end up with subtracting 3y minus 3y. I end up with x equals 1 minus 3y. I then substitute that into my other equation. I have 4x plus 3y equals negative 5. So I'm going to replace x with something. 3y equals negative 5. And I replace x here with that, so I have 1 minus 3y. And then I solve. Again, we know how to solve from yesterday, so I'm not going to do this. So, kind of just to look at this one more time, if we have a coefficient of plus or minus 1, like right here, we had a coefficient of negative 1, we solve for that variable and then substitute. If not, we look for common factors in each term. This term is divisible by 2, divisible by 2, divisible by 2, and when we do that, we end up with a coefficient of 1. If not, then this is not the most practical way to solve because we don't want to deal with fractions. All right, I hope this helps. I hope you enjoyed it. Don't forget to take the quiz and have a wonderful day. Or I guess I'm supposed to say, and have a great day.